Welcome to this video lecture on the topic, the regression line. A regression line is used for estimating the value of some variable y, which is not easy to measure directly. So instead, if we know that y is related to another variable x, we can use the value of x to estimate or predict the value of y. The regression equation takes a simple form: y equals a plus b times x. So there are two parts to the equation. A, which is the value of y when x is 0. If you like, is the value of y at the beginning. And then b, which is the rate of growth of y. By how much does y grow every time x increases by 1? Take, for example, a taxi fare. If we're going to travel a certain distance in a taxi, we might like to predict what the fare would be. So the fare is calculated as follows. When we sit into the taxi, before we begin our journey, even though the distance travelled is 0, there is a fare owing, the standing charge. And so there's a value for A. Maybe it's €4.50. So there's a certain quantity, y, a certain fare which is due even when the distance travelled is 0. Then as we begin to make the journey, every time we travel for a kilometre, the fare typically will increase by a certain amount, let's say €1.50. Travel another kilometre, another €1.50. And another kilometre, another €1.50, and so on. So as x increases, y increases, in this example, at a fairly steady rate. So the fare that is due at the end is y equals a plus b times x, where x is the number of kilometres travelled. So every regression equation takes that form. A is called the regression constant, and b is called the regression coefficient. Although in geometry, these are often called a is the intercept and b is the slope. Now, there is a special case when a equals 0. A equals 0 means that the value of y at the start is 0. For example, if you go to a grocery store to buy bananas, and having thought about buying bananas, you decide to buy no bananas. So the quantity of bananas you buy is 0 kilograms. That will cost you €0. It's not like taking a taxi ride, where even at the beginning there is a certain amount owing. So if the value of y is 0, when the value of x is 0, then we say that a equals 0, or we can say the line passes through the origin. Or we can also say that y is directly proportional to x. If we have a situation where b is 0, then the regression line is not useful at all. For example, the cost of a TV license is €160. If you watch no TV, it's still €160. And no matter how much extra TV you watch, it doesn't change. So the value of b is 0. There is no relationship between the price of the license and the number of hours of TV you watch. So in that case, it's not useful to construct a regression equation at all. So if b equals 0, the regression equation is not useful at all. If b is any other value other than 0, the regression equation is useful. And if a is equal to 0, the regression equation becomes that little bit more interesting, because the line passes through the origin and y and x are not only related in a linear way, but they are directly proportional. Now we can use a regression equation to predict the value of y by substituting the value of x into the equation. So if we have some values of x and y and we construct a regression equation, we can then take a new value for x, put it into the equation and estimate the value for y. And that gives us a predicted value for y. If the value of x that we use is inside the range of the sample data, then we feel quite confident that we've got a good prediction, and that's called interpolation. But if the value of x that we've used is outside the range of the sample data, we call that extrapolation, and we cannot place a great deal of confidence in our result because we don't know if the relationship will continue outside the range of the data that we have observed. For example, with an economic situation like the property crash or the COVID-19 pandemic, There may have been linear growth in a certain business, but then suddenly, when you predict for 1 month in the future, the predictions are very much in error. So extrapolation must always be carried out with caution. But so long as we're inside the linear range, we can have a good deal of confidence in a prediction that we make using a regression line. You can read all about this in the textbook in section 6b.